Now here is Unit 33, Important Organic Substance. Now in this section, we're going to study how the chemical reaction we just learned in the last chapter related to the chemicals in our daily life. And here, we will try to use 3 kinds of substance. The first one is acetyl salicylic acid, which is a drug. In common name, we call them aspirin. The second one is we want to study the structure and the chemical properties of soaps and soapless detergent. Finally, we are going to discuss the structural properties of nylon and polyester, which is a special kind of polymer, a little bit different from what we have learned in the previous section. So we start. First is aspirin, and here shows the structure of aspirin. So please be careful, because in examination we will not ask you to draw it, but at least you need to name the functional group of the aspirin. Now first, you can see the green circle, we have carboxylic acid. Then for the blue circle, now please pay attention. For the blue circle, you can see a CO double bond, but this is not a ketone. Okay, this is an ester. This is an ester functional group. So at least in the examination, you need to give me the name of these 2 functional groups. Now, what is the use of aspirin? The first one is relieve pain, for example, headache. The second one is reduce inflammation and cleanse the blood, because for some patients their blood may be too sticky. We say the viscosity is too high, so they have a risk of blood clotting and heart disease. And aspirin is proved to have obvious effect on relieving the heart disease. Okay. Yeah, the fourth one is a bit difficult for us, so we just give it up. And same as everything, aspirin also have side effect. The most significant side effect is the stomach bleeding. Okay, so that means for those patients who take aspirin so often, they may suffer from the stomach bleeding. And the others is okay. Again, this is a bit difficult for us because this is not a biology lessons. Okay, now in here we show some extra information for you. Okay, now the aspirin, you can see, yes, this is a carboxylic acid and an ester group. It can form hydrogen bond with water, yes, but because it contains a non-polar part, okay, we use a black circle. This black circle is non-polar part. And you can see this is a benzene ring, contains 6 carbons. So because the non-polar part is so large, this reduces the solubility of aspirin, and hence scientists try to improve the solubility, because if the drug is more soluble, it will absorb by our body easier. Okay, so what should they do is, by neutralization, we introduce a cation, sodium ion inside. Through neutralization, the carboxylic acid is neutralized to form a ionic salt, because ionic compound, or we can say the sodium compound, are always soluble, so this will introduce the solubility of aspirin. But as I mentioned, there are so many side effects for aspirin, so the doctors are restricted or forbidden to dose the aspirin to the children under 16. So what about for those children, if they suffer from the headache, so what drugs they should have. And here we have introduced an alternative is paracetamol or simply Panadol. But Panadol is actually a brand name, okay? It's a company's name. So this is what you see, the Panadol. Now, unlike the aspirin, which contain a carboxylic acid, here shows a Panadol structure. Oh, okay. Again, no need to memorize the structure, okay? But all you can see is, first, it got a hydroxyl group, and here is an amide. Okay, this is hydroxyl group and an amide group. Okay, again, you no need to draw the structure of paracetamol to me, but you need to, or you are requested to write down the functional group it contains for a given molecule in the examination. Okay, now unlike the aspirin, okay, paracetamol don't have carboxylic acid. That means its pH value will be not as low as the aspirin, or you can say paracetamol is less acidic, and that's why it have less corrosive to the stomach. Okay, but on the other hand, the effect of paracetamol will be a bit different. It does not reduce inflammation. Okay, now here shows the checkpoint. So let's see. Do you remember the functional group exists in the aspirin tablet? Now, so first, it contains a carboxylic acid. Yes, both A, B, and D have, and one more functional group. Yes, it's ester. So B should be the correct answer because it got a carboxylic acid and an ester functional group. The second one is, okay, which of the following statement about aspirin is correct? Okay, sure, we just discussed it contains an ester group. It is a painkiller. Yes, if you suffer from the headache, you can use aspirin to relieve. And yes, low dose of aspirin can prevent heart attack or heart disease because it reduces the viscosity of the blood. So D will be correct. Now, 3 here. Okay, paracetamol. Okay, here given the structure. So which of the following functional group not represent? Okay, let's see. Now again, you see a CO double bond here, but it is not a ketone. Again, okay, you should see what it is surrounding, and you can see there is a nitrogen surrounding, and this is a OH. Okay, so sure, we got an amide and hydroxyl group, and yes, we got a benzene ring. Here is the benzene ring. So that means ketone is not exist. Okay, next one. Which of the following are the major product when aspirin is heated with sodium hydroxide under reflux? Okay, now again, you are recommended to memorize the functional group. Okay, the functional group, it exists. At this moment, maybe you can forget the position first, okay, because this is not so serious. Now, this is a sodium hydroxide solution under reflux. That means it's an alkaline hydrolysis and neutralization if necessary. So first, the hydrogen ion will be replaced by sodium ion. Okay? And the second one, as I mentioned, there will be a hydrolysis. Okay? Hydrolysis. And after hydrolysis, a H will be introduced in the alcohol part. So 3 will be the answer. And we don't have free only. So what should we do? The answer is, how about this one? Okay. How about this one? This is an alkali hydrolysis. Of ester. Okay. Ester react with water to give you carboxylate ion and alcohol. Now, we got an alcohol already. Okay, the alcohol is shown in the or connected with the benzene ring. So what will be the carboxylate? Where it goes? Now, this will first turn into the carboxylic acid and then become carboxylate. And here shows this is our first choice. Okay, so the answer should be 1 and 3 only. Okay, next one is the how the aspirin is produced. Okay, in long time before, okay, the Chinese doctor found that as the component or ingredient of aspirin is exists in the bark of a willow tree. Okay, but okay, not exactly as the same of aspirin, but if if I extract the drug from the willow's bark, it will take a long time and the yield is very low. Okay, even though the source is natural. So what should we do is we try to make it in the laboratory, and here is the salicylic acid, which is the raw material of making aspirin. Now, here you can see the salicylic acid looks like the aspirin. You got a acid and an alcohol. Okay, so here shows after reaction 1, it become aspirin. So the OH group become an ester group. So I think all of you can understand the reaction condition. It is esterification, and the suitable reagent, it should be first. Let's see. We break down in the CO bond. Then we need this part exists as an acid. So we need even lower acid. And how about the conditions? The conditions will be esterification condition. That means we need corn sulfuric acid as a catalyst. Okay, and the condition will be reverse. Now, heating here not so suitable because reverse means heating for a long time. So I think reverse will be better, even though in most cases they exist similarly. Okay. Now the second one is a second reaction. Now, oil of wintergreen. Now this time the OH group is preserved. Okay, we just move the COOH into another ester group. So again, we break it here, and what we need is this one. This is come from an alcohol. This is methanol. So again, the condition will be concentrate sulfuric acid and reverse. And here shows. So you can see the reason we learn the chemical reaction for the last section is because we try to introduce into daily examples how we can produce the aspirin or oil of wintergreen from the salicylic acid given. Okay, so here is the part of aspirin. Okay, it's a bit short, and the focus will be try to learn the esterification. Now, here we move to the detergent part. Detergent part, I think this is the most important in this section. Okay, now first, here introduce, we have millions choice of detergent in our daily life. Okay, from soap to the shampoo, to the washing solutions. Okay, for the washing the dishes. Okay, many of them. Okay, toothpaste is not included here. Okay, toothpaste is another story. So here we try to divide all kinds of detergent into two groups. The first one is soapy detergent. It got one and only one member, is the soap. Okay. For the rest of them, we all classify as soapness detergent, or sometimes we call them synthetic detergent. Okay. So how can we determine which one is soapy and which one is soapness detergent? And here shows. Okay, first we move this part first. Well, for the soapy detergent, okay, it got first a strict chain of carbon chain, and the second one is it got a carboxylate ion. Okay, so if the substance fulfill these 2 points, then it should be classified as soapy detergent. And that's it. Okay, so we will talk this later. So we try to study the detergent in 3 aspects. The first one is what it looks like, the structure, and how it cleans. Okay, now first, this is the structure of all kinds of detergent. First, it has a hydrocarbon tail. Okay, sometimes or some textbook we call them non-polar tail. Okay, some textbook will use this name, that doesn't matter. The non-polar tail or the hydrocarbon tail, they got a very important properties. Now, this is so important that you should memorize or spell this word. Is hydrophobic. Hydrophobic. Okay, so maybe you have learned it in your English lesson. Phobic means something we fear. Okay, we are afraid. So hydrophobic means they are afraid of water. And sometimes some textbook will say this is water dislike or water repairing. It doesn't matter, the meaning is the same. Now, but only the hydrocarbon tail is not enough. We need a ionic head. Ionic head means this is a cation or anion or anything that carry real charge, not delta positive or delta minus. Okay, it's a real charge with the charged ion. This is what we call hydrophilic. Hydrophilic means water like. They try to dissolve in water. Okay, and here we give you the origin of how these 2 words comes from: hydrophobic and hydrophilic. Now, so how can we understand the structure of the soapy detergent? Why we call them soapy? Because they come from natural fat or oil with alkaline. Now, natural fat, okay, maybe what you can relate it is oil or peanut oil, vegetable oil, or even butter. Okay, but here, remember, paraffin oil is not kind of natural fat or oil. Okay, paraffin oil not included. So do not try to use paraffin oil or petroleum. Okay, well, they are natural, yes, but they are not included in here. Okay, so after mixed with the natural fat or oil with alkali, then by alkali hydrolysis of ester, you will form this kind of substance. Okay, as I mentioned before, we got a hydrophobic tail, which is a carbon chain, long carbon chain, and a hydrophilic head, which carry charge. Now, here shows if it is soapy detergent, if it is come from natural source, then it will be a carboxylate ion. That means it carry negative charge. But you need to memorize or need to be careful. This one is not the mobile ion, the sodium ion is not kind of hydrophilic head. Doesn't count to be hydrophilic head. Okay, it is not included. Okay, so that's why in this picture we haven't included the sodium ion, potassium ion, whatever. Okay, no. Sometimes for the schedule formula we use this one to save our time. Okay, this is the natural source soapy detergent. How about those non-soapy detergent or soapless detergent? Okay, this is man-made, so we have many choice, but it also carry the hydrocarbon tail, but the ionic head will be some kinds come from sulfuric acid. That means they have sulfonate group or sulfate group, and we have other millions of choice. Okay, so no need to memorize. Okay, no need to memorize how the ionic head looks like in the soapless detergent, because we have many choice. Okay, but maybe you can relate that if the ionic head contains sulfur, maybe it comes from sulfuric acid. Okay, this is correct. And unlike the soapy detergent, the soapless detergent is come from petroleum. Okay, it's come from petroleum. That's why when there is a petroleum shortage, the price of soapless detergent will increase. Okay, and here shows, yes, we have, as I say, we have millions choice of soapless detergent. So here shows some unusual one. Okay, again, no need to memorize, just let you know it's okay. We have negative charge ionic head. Is it positive for or is it possible to have ionic head in positive charge? The answer is yes. Okay, and here shows. So is it possible for us to have a ionic head that carry highly charged but not highly polar but not charged? Okay, yes, here shows. And for those students who study biology, and this one will be looks familiar to you or sounds familiar. This is biosalt. Okay, it more or less the same as structure we mentioned before. Again, a positive or a negative charge head, and then comes followed by a long carbon chain. Okay, in next section we are going to discuss how the detergent works. Okay, why for the oily or greasy substance they can be removed by the detergent but not by the pure water only. Okay, so stay tuned and we will see next section.